All right, this is our week 6 video assignments. We're going to be looking at day 1's video right now. This is the temperature conversions is one of our first topics. So let's look at the following. The US and metric systems use different scales to measure temperature. The US system uses degrees Fahrenheit, written as a circle, that's our little degree symbol with a big F. The metric system uses degrees Celsius, written as the little degree symbol and a capital C. The figure below shows the relationship between the two systems. So notice that a lot of times people like to use the Celsius system because water freezes at 0 degrees Celsius and water boils at 100 degrees Celsius. 0 and 100 are very simple values when you think of freezing and boiling. That would put the normal body temperature for a human at 37 degrees Celsius. Now, we're going to give you the formulas for conversion in just a minute, but if you look at the US measurement for temperature, we have that water freezes at 32 degrees Fahrenheit, water boils at 212 degrees Fahrenheit, and 98.6 degrees Fahrenheit is the typical normal body temperature. So these are the equivalent temperatures. So if you have a thermometer and you take your temperature and it reads it in Fahrenheit, you would be closer to this amount if your normal health level is exactly where it should be. And then if you did it in a temperature that reads in Celsius, 37 would be what you would be looking for. So that's kind of just a diagram to help us visualize there. Now, here are the formulas to convert. Now, based on which one you are given, that determines which formula you will want to start with. So if you're given Fahrenheit, you'll want to use the formula that has the Fahrenheit over here with all the numbers going on, okay? So this is the formula to convert from Fahrenheit to Celsius. It's C equals 5/9 parentheses F minus 32, what we put in our Fahrenheit degrees. To convert from Celsius to Fahrenheit, so if we're given the Celsius temperature, we use this version. And all they did was resolve this equation for the other variable, but we give you both on your formula sheet. So F equals 9/5 Celsius plus 32. So here's an example. Convert the Fahrenheit temperature to degrees Celsius. So we have 41 degrees Fahrenheit we're given. We're starting with Fahrenheit, so we'll use the formula that solves for C. So that was the top one. C equals 5/9 parentheses F minus 32. First step is to plug in your Fahrenheit. Then we're going to use order of operations. So we're going to subtract because this is in that parentheses first. So 41 minus 32 is 9. Then we would multiply 5/9 times 9. Now 9 is like 9 over 1, so the 9s would reduce or cancel out, and we'd just be left with 5. So 41 degrees Fahrenheit is 5 degrees Celsius. Let's convert this one. So we're going to start with degrees Celsius and go to Fahrenheit. So we're going to be using, I'm going to write this formula down here. We're going to be using the one where we have the Celsius in the middle of all the numbers. So 9/5 times C plus 32. Notice this one does not have a parentheses. So when we go to work this out, we're going to work out the multiplication first and then add the 32. So this will be 9/5 times A. This is -6 plus 32. So let's get our calculator out. So 9 divided by 5 times 6, that is negative. So you'll need to use your negative button on your calculator. That's negative 10.8 plus the 32. We get 21.2 degrees Fahrenheit. So -6 degrees Celsius is 21.2 degrees Fahrenheit. Now, we're going to use what we've been learning about the factor label method to do some conversions between the US measurements, like inches, feet, yards, to the metric system of measurement. So if we're doing things like centimeters, meters, kilometers. So many measurements in the United States are made in metric units. Our sodas may come in 2-liter bottles, our calcium may come in 500 milligram capsules, and we may run a 5K race. We want to be able to work easily in both systems, so we need to be able to convert between the two. So like a ruler, something that you've used probably multiple times in your life, if you look at it, usually there's two sides to a ruler. There is an inches side, which is our US measurement, and then there's the centimeter side, which is the metric system measurement. Notice that about 1 inch, if you drop down from there, that one long line, we're a little bit above 2.5 centimeters, okay? And there's actually a measurement down here that we can look for that. So notice that 5 inches and change is roughly almost 13 centimeters, a little over 12 centimeters. Okay, so here are the conversions. Now, these are on your formula sheet. You do not have to have any of these memorized. And honestly, a lot of times the Newton homework questions and quiz and exam questions, they will sometimes tell you what conversions to use, which makes your job even easier. You just have to know how to set up the factor labeling. So we know that 1 inch is equal to 2.54 centimeters, 1 yard is 0.914 meters, 1 mile is 1.61 kilometers, 1 meter is about 3.28 feet. Notice they switched which side was metric and which was US there. 1 pound is about 0.45 kilograms. 1 ounce is about 28 grams. 1 kilogram is about 2.2 pounds. Now these should all kind of be approximately equal. It just did not format that correctly, but if you look on your formula sheet, I believe it does have the approximates. 1 quart is about 0.95 liters. 1 fluid ounce is about 30 milliliters, and 1 liter is about 1.06 quarts. So length, which is measurement, that we like, how long is something, mass, which is weight, and capacity, which is how much can something hold, like our water bottles and things like that. Okay. So here's an example of using one of those conversions up there. I want to take 14 inches to centimeters. So notice we do it just like we did when the US conversions. We start with our 14 inches over 1 times, and then I want inches to cancel. So I already put the inches down here before I ever did anything else here. And then I look up in my table and I say, is there a connection directly between inches and centimeters? And we do have one. So that allows me to put the centimeters on top. Then we place the numbers next to their correct units. So 2.54 goes with centimeters, 1 goes with inches. We cancel out the inches before we multiply. I did 14 times 2.54, which gave me the 35.56 over 1 times 1, which is just going to be 1. So when we divide that, we still get 35.56 centimeters. So there's the answer for that one. Let's do another one. So we want to convert 4,300 centimeters, so that's what we're starting with, to inches. So I know right away I want centimeters to cancel no matter what my top unit is. I look up here and say, is there a direct connection between centimeters and inches? We do have that. So inches can go on top since we have a connection. This time the 1 is still staying with the inches, but the 2.54, remember, is staying with the centimeters. So it's going to be in the bottom this time. So on this one, we are actually getting 4,300 over 2.54 because we're multiplying both of those by 1. And we would divide that on our calculator. So 4,300 divided by 2.54. That's going to be 1, and we're going to round this to, let's 1 decimal place for this one. They didn't give us that in the directions. So 1,692.9. And that would be, inches. So about 1,693 inches. Okay, let's look at another one. So this one is one like in your homework where they will actually give you a set of directions. But in this one, I did write a note. In Newton, they did it this way. They gave you all these connections, but there is an actual path directly from yards to meters. So honestly, that would be the better and quicker path. I will show you both just so you can see how sometimes using a different path might give you a similar answer that might round slightly different. Or it could be the same. That's why I said usually you should probably go with what Newton has given, just because they specifically expected you to use that pathway. So 9 yards is what we're starting with of fabric. We want to know how many meters. So we're trying to get yards to meters. And instead of using this one directly, let's go through the path that Newton gave us. So I want to get rid of yards. And the directions they gave me is that I can convert yards to feet. Okay, so let's go ahead and put our numbers in. 1 yard is 3 feet. Yards are gone. Then I'm trying to get to meters. So I'm going to use feet to inches next, because that's another one they gave me. Feet need to go on the bottom, so it'll cancel. So I'll have inches on top. 12 inches is 1 foot. Now we're in inches. They said inches have a relation to the metric system if we go to centimeters. So they have that 1 inch is 2.54 centimeters. Notice I wanted inches to cancel out. And then lastly, the fact that 100 centimeters make up a meter. And that is going to be what we talk about in our notes, because I said we were going to cover the metric system together in class. So 100 centimeters, since centimeters needs to cancel, it needs to be on bottom, is 1 meter. So this is a long way about going to just get to meters. So if we multiply all the top numbers, we get 9 times 3 times 12 times 2.54 times a 1 would still be 822.96. All the bottom numbers are a 1 except for the last one, so I'm going to be dividing by 100. So we're going to get 8 did they tell us to round to 1 decimal place? Always read your directions on that. 8.2 meters. Okay, now this was what Newton expected us to do. That's for our homework. Now, if I looked at our formula sheet, again, I could have seen this path from our formula sheet that there was given information of how to go from meters to yards. We already had that. So 9 yards over 1. And then this is yards to cancel. This is meters on top. So it's the 0.914 over 1. Let's see what we would have gotten if we'd used the more quick path using our formula sheet. 9 times 0.914. Notice we still get 8.2. So in this scenario, this specific case, we would have been okay either direction. I do know that some of them you might slightly be off. Maybe you get an 8.1 if you use one path, but somebody else would get an 8.2. That's why I just say I will look at your scratch work on the test when you turn that in. And if you've used a valid path that has connections that we have on the formula sheet or the ones that Newton have given you, I will give you the full credit as long as you did the pathway correctly. So just FYI, if you're worried about homework, use their specific directions. That way you don't get problems marked off because possibly a rounding issue occurred. Most of the time you should be okay. All right, so let's look at another one. An average household of 2 in America will throw away 180,000 pounds of trash over their lifetime. Convert this weight to kilograms. Okay, so we're going, that X of 2 is just an extra piece of information. That's just how big the household is. Doesn't mean each person is throwing away that trash. It's the whole household is throwing away that trash. So we're starting with 180,000 pounds and we want that to go to kilograms. We do have a Newton piece of information that 1 kilogram is 2.2 pounds. So we're going to put pounds on the bottom to cancel, kilograms on the top, 2.2 and 1, round to the nearest 100. Notice I highlighted that because sometimes they will do this and it doesn't have the TH. We're not going to decimal point here. So this is just going to be 180,000 divided by, oops, not 2, divided by the 2.2, since that's on the bottom. And I'm going to write out what we have first, then we'll round it. So it's 81818.1818 ... It keeps going on forever. They said round to the nearest 100. The 100 place is this 8 right here. Okay. So we look at the number behind it. It's a 1 that will not bump that up. So this is 81,800 kilograms. Okay. So just make sure you're reading your rounding directions correctly. All right, this next one says convert 40 kilograms to ounces, where we have these informations, kilograms and pounds, pounds and ounces. So we're starting with the 40 kilograms over 1. I'm going to go to pounds next. So kilograms need to go on bottom to cancel. Pounds would go on top. Put down our information. 1 kilogram is 2.2 pounds. Mark out the kilograms. Oops, times. This is, sorry, my tablet's having a little bit of a connectivity issue. There we go. And then we have pounds needs to cancel and leave us with ounces. And we know that 1 pound is 16 ounces. I highly recommend if you're using the shortcut for the word pounds, it looks like a 1 sometimes. So I always make sure I put a space there between my number because that could look like an 11 on accident when you're doing your work and like we're trying to write it out. So leaving that space between the number and the units is just helpful so that you don't misinterpret your values that you wrote down. Just a tip. So then this is all multiplication across the top. So 40 times 2.2 times 16, that's going to be 1,408 ounces. Okay. And again, Newton usually doesn't have you write in the units, but you should show that on your scratch paper. Okay, the last part for the day 1 video is I skipped over 6A2. I wanted to do that in class, but 6A3 is over health science applications or dosage calculations. We do quite a few of these in class as well, but I wanted to make sure that we're going to have enough of those for you to practice. So I wanted to do some on this pre-video. So dosage instructions. Drug manufacturers will often give dosage instructions in the following format. They'll say you need to take this many milligrams per kilogram of your weight per day. This means that the appropriate dosage is X milligrams of medication for 1 kilogram of your body weight per day. So we're going to look at how to convert a person's weight and using a prescription of medicine from the doctor to figure out how much they should take per dose. So it says, look at the drug's dosage and or concentration information. This will be used as a conversion factor in determining dosage. Determine whether the given information, such as the patient's weight, must be converted into matching units. So if we give you the person's weight in pounds and the drug dosage is in kilograms, we will have to make that conversion first. Gather all the conversion factors needed and use the factor label method to calculate the correct dosage. So I have one completely worked out that we're going to read through. It says the dosage for a certain drug calls for a patient to receive 35 milligrams. This is per 1 kilogram per 1 day. That's how you read that, which we're going to divide that amount into 2 doses, which means every 12 hours. So this is for the whole day. We're going to have to split our answer in half by the end because we want to make sure we give them the right amount per dose. If the patient weighs 225 pounds, how much of the drug should they get in each dose? Round to the nearest whole number. And then they remind us to use this conversion factor. Note that this medication is based on weight in kilograms for the patient. So we need to take that first. With 225 pounds is what we start with. The patient, you always start with your patient. You convert them to the correct measurement for the drug prescription. So now this will get them in kilograms if we worked this part out. Then this is how we set up the drug prescription. It's 35 milligrams, and this is, again, a 1 kilogram per day. Okay, now this, if you stopped right here, this would tell you the amount of medicine they need to take for an entire day. We want to know how many they should take per dose. Notice they said each dose. So this last step is to cancel out. So we're kind of canceling out kilograms on this part and days on this part, this last piece. We're saying that 1 day of medicine is going to be split into 2 doses. So that's just taking the overall full day of medication and cutting it in half. Okay. So this ends up giving me milligrams per dose once we're done. So I worked this out and I'll just show you on my calculator. And you can do this from left to right. We've always done all the top and then all the bottom and then divided. If you go very carefully hitting enter between each step, you can actually do the calculations as you go. So I'll show you that. You can do 225 divided by the 2.2, because this is, you multiply if it's on top, you divide if it's on bottom. So you hit enter, don't clear anything. The next number is a number on top, so we're going to times by that, so times 35, hit enter. And then the last number is on bottom, so we're going to divide our answer by that. Notice that comes up with 1789.7, and we're rounding to the nearest whole according to our directions. So that 7 bumps the 9 up, makes it a 10, which also bumps our 8 up because that 1 would carry. So that is how I got 1,790 milligrams per dose. That's what they should be taking per 2 times a day. They take that amount twice a day. Okay. So let's try one together, and this will be the end of our day 1 video. The dosage for a certain drug calls for 15 milligrams per 1 kilogram per 1 day. It's going to be divided into 4 doses, so every 6 hours. If a person weighs 140 pounds, how much of the drug should they get in each dose? Round to the nearest whole. So we're going to, again, start with our patient, 140 pounds over 1. The medicine is in kilogram weight, so I need to convert pounds to kilograms using our 1 equals 2.2. So 1 kilogram equals 2.2 pounds. That's going to get rid of the weight in the wrong metric. And then we're going to use the medicine next. We're going to prescribe the medication. So 15 milligrams of 1 kilogram per day. So this is going to cancel out the kilograms. And then we want that to be 1 day's full medicine is going to be split into 4 doses. Okay. So if I multiply across the top, I have 140. Actually, let's just multiply as we go. So 140, then we divide by 2.2. And then we times by 15 since the next one is on top. And then we divide by 4 since we're splitting it into 4 doses. That tells me 239, if I round to the nearest whole, milligrams per dose. Now, that's the same answer I would have gotten if I'd done all the top multiplication. So 140 times the 15, so everything else is a 1, so that'd be 2,100 divided by, and I would have to have already worked this out, so I'm going to put it in parentheses, 2.2 times 4, which is 8.8. And then notice I get the 239. You don't want to do the full amount divided by 2.2 and then write times 4 without that parentheses, because it will only divide by the 2.2 and then it multiplies your answer by 4. So if you're going to use the multiply across the top, multiply across the bottom, and then divide, make sure you write all of those numbers out before you do the division step. Okay. All right. That's the end of our day 1 video.